All right, so let's take a look at rates of change, right? Before we do any rates of change, I want to make sure that you all remember how to differentiate. So I'll give you one quick question. Differentiate this, please. Right, so before we begin, differentiate this, please. Differentiate for me, y is equal to 2x minus 1 by 5x plus 2. Differentiate that fast before we begin rates of change. Right, differentiate that quick. You have two things they could do. But that's two, remember. Huh? Yeah, you can cut product rule if you want. Or because it's so simple, you can multiply it out. Anyone you want. One minute again. So I am using product rule, right? I'll tell you what that is. Wait, not later, but I want to pick my now. Well, yeah, after 9:30. It doesn't work out. What time is coming on time? I know how to get it. All right, so let's see. I am in product rule, right? So u is equal to 2, dvdx is 5. 2x minus 1, sorry. dvdx is 5, v is 5x plus 2, dudx is 2, right? So this is 10x minus 5. This is 10x plus 4. When you work it out, 10x plus 10x is minus 5 plus 4 is minus 4. All right? So it's just a quick reminder of what we're doing, right? Differentiation. Let's focus now on rates of change. All right? So if I say, for example, y is changing at a rate, right? Or actually more formally, rate of change of y, right? That sounds a little better, right? Rate of change of y. All right, rate of change of y. So therefore, you write it like this: dy dt. Once you see the word rate, it has to do with how something changing with respect to time. Okay, how do we find dy dt now? Well, we go back and we use chain rule. I remember that chain rule. Here is dy, here is dt, and here is whatever variable you're using next. Remember that? So for example, if I said rate of change of volume, that is dv dt. How do we find dv dt? You have dv, you have dt. Here is your dB and here is your dt. Right here and here will be the next two variables. Right? So the next two variables are what? Right? Most likely is radius, right? Because volume is radius. So it might be R here and R here. Are you okay with that? So you need to pay attention to what they're asking you, right? This here, for example, is the rate of change of radius and so on, right? So how you know a rate of change question? You will see the word rate, right? If they ask you to find dB/dt, then you're going to use chain rule to obtain dB/dt, right? dB/dr by dr/dt, and so on, right? So we're gonna start with some easy ones and then build up into some hard questions, right? Huh? Yeah, because it's the home today. Okay. All right, let's start. So you want to take a look at some rates of change type questions, right? Let's do a couple from here. Right, rates of change is normally one of the harder things, right? So let's focus on number one. Right? Take a little read. The radius of a circular blob of ink is increasing at a rate, right? So let's call radius R. Right? So they said the radius is increasing at a rate. Once you see the word rate, you know that's what? And that'll be dr/dt, correct? So dr/dt is 1/5, right? Let's call that 0.2 centimeters per second. They would like you to find the rate of at which the area increases. Let's call the area A when the radius is 10. But okay with that? So what they ask you to find? D what? dA dt. So if we use chain rule now, what will it be? Here is it dA, here is your dt. Right, R will go here. dr, dr. We already know dr dt. What do we need to get? dA dr. So we need some kind of equation that will give us A in terms of R, right? And because it's a circle, what's the area of a circle? Area of a circle is pi r squared. So dA dr is what? Right? Bring down the 2 and you'll get 2 pi r. That's okay? You recognize that the differential is the circumference? And you can always anyway talk about that later on. But we need a value, right? R is how much? They would like when R is 10. They give it right here. Right? So when R is 10, we will get dA dr to be 2 by 10, which is 20 pi. That's okay? Am we done? dA dr, that's 20 pi. dr dt is 0.2. Right? 0.2 by 20 is 4 pi. Right? It'll be centimeters squared per second. Are you okay with that? Yeah? So the important thing, see what you have to find and develop the equation. That's okay? Copy it down. Do we get marks for units? If you have 4 pi, you'll get right. Right? If you have 4 pi centimeters squared per second, you'll look smarter. Right? But at this level, they'll give it here, right? Right, so we're doing a few of these. Some will be easy, some will be a little more challenging, right? All right, next one. Try number 2. Try number 2. What's the volume? What was the volume of a cone again? 4/3. What they give it here? 4/3 pi r cube here. 4/3 pi r cube. That's a part 3. That's a number 3, right? Right, try part 3 first, and then number 2. Try 3 and then 2. Because 2 is a little more work in the one, the total surface area, right? Try 3 and then I'll do 2. But you have a 5 particular amount, please. 5 page. Yeah, 5 page. Right, do the number 3 first, right? Right, online, anybody? If you all get part number 3, just message your answers, right? Put in here. And I could check out number 3. Or like number 3. So good. So let's check out number 3. What they gave us. H is the height. It remains constant, right? While the radius is increasing. So they said H is constant while the radius is increasing at a rate. So they gave us dr dt, right, which is 5. They want us to calculate the rate of change of the volume. Wait. Does it formula for volume? H now missing. Volume of a sphere. Oh shucks, that was sphere I gave you there. Oh no. Gave you the wrong formula. That's my fault. Because they wanted to find dv dt. Hold on, I'm gonna just look for it. Given that the volume of the sphere is R and the surface area is that. Volume of a cone is H. Sorry about that. The H missing. Huh? Right, so the H is a constant, right? So it will look something like this, right? We want to get dv dt. So we know that dv dr by dr dt. So we need to get dv dr. So we know that v is equal to 4/3 pi r cubed. But they said H is a constant. So you could treat H just like pi. Right? Let's put H here. By r cubed. When you differentiate this, what you'll get? Bring down the 3, you'll get 3 by 4/3 pi H multiplied by r squared. So you will get dv dr is equal to 4 pi H by r squared. And the question said when r is what? When r is 60. So this is 4 pi H by 60 squared. Right, and then you can work out that from how much? You can leave it in terms of pi. How much is that? 17,000 pi H. So that'll be 1,000. 72,000 pi H multiplied by 5. Oh, that's the final thing. All right, well, all right, in this value here, right? So it will be 4 pi H by 60 squared multiplied by 5. And you got 72,000 pi H centimeter cube per second. All right. Sometimes just give you a value for H, right? In this question, it did not. Number 2. Let's try number 2. What's that? Let's try number 2. Take your time, right? They said total surface area. Right? How you find surface area of a cube? Right, 6 by all the sides, right? Right, you can call side S if you want. It's up to you. Try it quick. Any answers? Any answers at all? So what do we have? We have DSD, we have DSDT, right? Yeah. DSDT is 2. They want us to find total surface area. So let's call it A for now. They want us to get DADT. So that'll be dA, dt, ds here, ds here. What's the equation we're going to use? A is what? Right? So it's s squared by 6, right? So 6s squared. So we know that dA ds is 12s. We have a problem. We don't know s. But we know volume, right? Can we find s? Yeah. So volume is what? S cubed. Correct? So s cubed is equal to 125. So therefore, s is what? S is the cube root of 125, which is 5. Right? So you have to kind of work backwards here. Well, not backwards. You have to find a way to find s. So that means that what? dA ds is equal to 12 by 5, which is 60. Yeah. But I reached there yet. I'm now finding dA ds. Are you okay with that? Clear? It's a hog ds, right? Any questions online there? And when you have one answer, it means we get some trouble. How you found A? Oh, it's a cube. So you have 6 sides, right? And they all will have the same area. And the area is s squared. And I multiplied by 6, right? Okay, and you work it out, right, Ethan? You okay with that, Ethan? So come back on top now and finish it off. The ADS is 60, the SD is 2. So that'll be 120 centimeters squared per second. Anybody got that? Good. Let's go again. I want to go harder, but don't think I'll do it as yet, right? So the basic idea is to differentiate the formula, yeah, and then find what quantity you need. Good job, Arya. Arya message a long essay there, right? Right, nice. Arya, you there still? Safir, you send anything, right? Who's Safir? Christopher. Christopher not there. All right, good. Let us do our next one. Copy down quick. Let's do one more easy one. Which one here easy way? All right, 9 looking easiest. Try number 9 here, please. Well, of course, 9 and 10. But let's start with 9, right? Right, Ethan, similar answers, right? Take your time with number 9. Oh, let me just give you the correct formula this time. The area of a spherical balloon is 4 pi r squared, and the volume is 4/3 pi r cubed. Okay? 4 pi r squared for area. And 4/3 pi r cubed for volume. Try this one. Those who online, message your answers, please. Ethan, if you could send me one answer for the day, that would be good. Safir, you too. Just one. All right. Right, Jamie, Sivan, just one answer. Wait, Josiah, you there too? I cannot believe that. And I didn't even get one answer. Okay, you give me one from before. All right. I sent one so far. Go ahead, try number 9, and then we try one at a little bit harder, number 10. What else to define in this one? What is that? All right, let me see what we have. We have two answers from this whole class. No. Naisha and Kaylin, that's all I have. Two different answers, but we have answers nonetheless. Jaden, where yours? Ethan, Kevin, Keshav, Petal, Ranju. Come on, try something. Jivan. Right, let's see what you came up with. Right, so what they gave us here, Shibish, the what? Safira, can I answer, right? Yeah, what they give you, Shibish? Read the first line. What's that? So they give you dRdt, right? So dRdt is 0.05. Right? They gave you dRdt. Okay? What they ask you to find? They ask you to find the rate of increase of surface area. So they want dA dt. So that'll be dA d something by dt. So you know it's R because that's the next variable you're working with. That's okay? You already have this, right? You already have that. So it's just to get dA dr, right? So we're coming back here now. We know that A is equal to 4 pi r squared. A is equal to 8 pi r. Sorry, dA dr, sorry. Again, we don't know R. How we get in R? make R the subject in the formula with V, right? So they told us that the volume is 972. They said that the volume is 972 pi. That's equal to 413 pi R cubed. Are you okay with that? So the pi's will cancel, carry across the 3 and divide by 4. So that's 972 multiplied by 3 divided by 4 R cubed. Okay? And then they cube root the whole thing. How much you got? 9? 9, so R is 9. So now we come back here now and we say that dA dt is equal to 8 pi multiplied by 9 multiplied by dr dt, which is 0.05. Right? And you can leave your answer in terms of pi, or you can write the actual value. How much you got? 18 pi on 5 centimeters squared per second, or 3.6 pi, or 11 point what? 11.3. 11.3. That's okay? Yeah. Any questions online? Right, everybody who messaged got it right. Ariane, you left a pi, right? Kaylin, I don't know what is that, no unit. Naisha, good. Amanda, good. Jaden, good. Safir, Dimitri, Ariane. Right, the others, you're paying attention. Suri? Jivan, you didn't send me anything as yet? Right, let's go again now. The more the merrier. Let's go again. She have to try it. Do you didn't write anything? Let's go again. This one I think a little bit harder, right? Yeah. Huh? Take your time, I know it's a little bit harder. So they said the base of a closed rectangular box made it closed, right? It's square. So the bottom of the box is square. So I'll try a little thing and draw it here for you. I'll do a little thing here that looking square, right? The bottom square. Oh wait, no, that's the wrong side. Anyway, let's pretend it's square, right? And its height is 8. Right? So let's say I gave you something like this, right? You have a rectangle here. A rectangle here. Let's assume the bottom of it is square. Right? So the bottom is x by x, right? And the height is how much? 8. Given that the side of the square base increases at a rate, so the bottom here, ds dt is 0.05. Find the rate of increase of the volume, and next part, total surface area when the area of the box is 210. So So they said that the surface area is equal to 210 centimeters squared. All right, try it now. I don't want to give you much more. So what you come up with? The height is 8, right? They want the rate of change of volume, so you have to work out that first. Then they want the rate of change of total surface area. So you have two things to work out. Right? And Elena will help us do it. So the first thing they ask for is dVdt, right? So dVdt will be dVdr multiplied by dr dt. The good thing, oh sorry, it'll be s, right? Sorry about that. It'll be s. The good thing is we already have ds dt. We already have that here. So we have to get dVds. So what is volume? What is volume of this cuboid? What's the volume of the cuboid? Right? Let's say it again. Well, length by breadth by height, right? Or 8x squared. That's what I said. Okay, 8x squared. So therefore, dv dx, right? Actually, I shouldn't really be using. I should be using their variable, right? X. So I'm using their variable. They said the side is x. Okay. So dv dx is 16x. So we know dx dt, we have to find dv dx. How do we get that x value? Celine, how will you get an x value? Right, we have everything else, but we do have that x value. Right, we know dv dx is 16x, and we know dx dt is 0.05. How we get that x value there? Celine? Any ideas? Anything? Anybody? Justin? From right here. Right? What's the total surface area? Oh wait, sorry, yeah, wait, yes, no. Let's make sure it's total. Yeah, total. Total surface area is what? You have to add up the area on all the sides. Right? You have to add up the area for all the sides. So let's deal with side 1 and 2. They are the same, right? That'll be x squared plus x squared, which is 2x squared, right? Let's deal with side 3 and 4. That'll be 8 by x plus 8 by x. And let's deal with side 5 and 6. That'll be what? X by 8 again. 8 by x plus 8 by x. So that'll be 2x squared plus 32x is 210. Right? Bring it across. You'll get 2x squared plus 32x plus 210 is 0. What you got for x? X is, so you'll get a positive and a negative value, right? X is 5. So that'll be 16 by 5 by 0.05. How much is that? How much? 4. So that's 4 centimeter cube per second. No? Where you get lost? And finding x. Right. The question told you that the surface area is 210. Right? If you have a cube, right, it's not really like this, right? But let's just say, if you have to find surface area, you have to find here, 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 and here. Right? These two are the same, right? These two are the same, and these two are the same. So I found here by here, the base is rectangular, so it's square. So that's x squared by x squared. Then 8x by 8x, 8x by 8x, and then here's a square, 8x by 8x. And I add up all 6 sides. And I made it equal to 210. So that turns out now to be a quadratic. And then I solve for x. All right? But you're not done. You still have to find dA dt. They said the rate of in surface area. Find dA dt, please. So for those who get lost then in finding x, use that x now to find dA dt. Josiah, are you there still? What you getting trouble with? Finding the x or the dv? Oh, getting the x at first, okay. Right, so somewhere in the question, it gives you a hint of how to get x, huh? Right, Ishana? Shivish, try dA dt. What would the formula be for dA dt, Lena? dA dx. Until we already have dx dt. You already have dx dt right here. How you getting dA dx? Shirish, how you getting dA dx? How you get dv dx? Huh? How you get dv dx? Look at right here. Huh? How I get that 8x squared? Huh? How I get that 8x squared? How you find volume? Right? So what's the length and the height and the width? And x by 8, that's how I get the volume. Right? So tell me how I get the area now. I did it for you already. What's the area? Hussein? Huh? Hussein, help him out there. What's the area? How much? The No, what's the equation for area to what's the equation for total surface area? Two x squared plus 32x. Right? We just worked it out, right? What's the differential of that Shivish? Shivish, I give you one video to watch to go over differentiation. What's the differential of this? 4x plus 32, right? 4x plus 32 and x is how much? X is 5, right? You found it earlier, right? So that's 4 by 5 plus 32 multiplied by 0.05. How much is that? How much is that? 2.6? 2.6 centimeters squared per second. Let's go again. We're going again. How much? 2.6. Good job, Jaden, Amanda, Kaylin. Let's go again. Let's go again. This time they'll give you the equation, right? Let's see if we can squeeze in the last one. Last one here. Right? Let's try and get this one, please. The hardest thing in this one is differentiating it. Okay? Try this one here. Online, could you send some more answers, please? Take your time with this one. They gave you what's volume, so you gotta work it out. What you have to do is make sure you differentiate correctly. Right, so they give you everything you need. This one will test the differentiation ability. Let's see how high it is. Try something. I'll pick up something by now. Right. Rate of increase of volume, right? So you know that fine. Right, we form it up. But it's up to you, you call H. H, right? You can call it depth H if you want. Yeah. That's what they did. They said it's depth of the container is H. You have no R. Right, H. I said use H. I don't want to use H. What's in it? All right. Nice. Any answers? Send them. Giving you some time. What else is the final Shavish? Which is what? Shavish, make your rise down the for you send my blood pressure up. Read back the beginning of the class and you will see what that is. At the beginning of the class, I told you what the rate of increase of volume. Did you write it down? So what do you want me to do now? We will write it for you. Come, let me write it for you in your book. Go ahead, take your time. Once you differentiate it right, it should be okay. And it's also important to use the right letters, right? Especially when they define what depth is and so on, right? Everybody got approved? I think we have the one statement. What's the margin? Yeah, what's the margin? Right, I've 9 answer. Okay, nice, a little better. Keisha, send me something, please. Josiah, feel you round up too much. Check back yours. Amanda looking good. Naisha looking good. Jaden looking good. Ariane, hey Ariane, you there still? Correct, Ariane. Ethan Bridgelal, can I get some work, please? Aria, send something now, please. Kevin, send something. Petal, Ranju. Sapir, Sean. All in back at the class there. Hurry up. All right, this is the last one that we're doing. All right, so let's take our time and go through this one. Good job, Heavy Shop. Correct. Right, so they want us to find the rate of increase of volume. So they want us to find dV dt. So we know that we have dV by dt. The variable here is the depth, which is h. So here is h, and here is h, right? Before we do anything, did they give us dV dH? Yep, right here. The depth of the water increases at a rate of 2 centimeters per second, right? So they told us that dV dH is 2 centimeters per second. You know, we shouldn't even write down anything. Right? And then they said now, if you look at it here, it's the same pattern over and over. They gave us volume this time. Volume is equal to 1/3 h squared by h plus 4. To differentiate this now, we have to multiply it out, or we can do product rule, right? So that'll be 1/3 h cubed plus 4/3 h squared. When you differentiate this, right? When you differentiate this, you'll end up with 3 on 3 h squared plus 8 on 3 h. Okay? When you differentiate it. And the question said they wanted when h is 5. So substitute h is 5. So dV dH is equal to h squared, which is 5 squared plus 8 on 3 by 5. Right? So therefore, dV dt will be equal to, I didn't really work out that. What's 5 squared plus 8 on 3? 38 and a third. So 38 and a third multiplied by 2, which is 76 and 2/3 centimeter cube per second. Huh? Yeah, you got the third. Right, nice, good. I think we have time for one more. We have 5 minutes, we can squeeze in one more. All right, so that's the first application of differentiation. Next day we'll do kinematics, right? Homework, look over the differentiation and the integration